We are room 9 from section 10. So first of all, I will introduce you my all members. So the first one is
Hello, my name is Siti Nur Idayu binti Sabri.
Hello, my name is Muhammad Amirul bin Muhammad Yusuf.
So for this project, our team need to find 100 of real data from SN student thesis, which consists of independent variable and dependent variable. So the thesis that we choose is titled Air Quality Monitoring System from Limwanta. So the field chosen is microelectronic. So the problem statement, the first thing is, this task is to enable the student to understand the actual data from SM student thesis entitled Air Quality Monitoring System in the field of electronic engineering that is collected and analyzed in general. Independent variable and dependent variable are two types of variables that are required from the thesis to produce a graph of statistics. And the third one, SPSS software will be used for this task to analyze the real data for complex statistical data analysis to analyze selected problem statement data based on given criteria. So, how the data is obtained? Firstly, in this project, the HT22 was used as the sensor to test the humidity of the air, and the sensor is connected to the general purpose input-output, which means GPIO of Raspberry Pi. The graph obtained from ThinkSpeed indicates that all the data from Raspberry Pi has been uploaded successfully to the ThinkSpeed IoT and provided real-time monitoring system on the humidity of the air quality. So, the graph result obtained from ThinkSpeed will be shown in figure that display the real-time of the next slide. This is the example of the result of humidity from ThinkSpeed. The next slide is the 30 data that we took from the thesis. So we know figure shows the result of real-time humidity. Firstly, this data has obtained from ThinkSpeed software, which display the real-time data of humidity. The dependent variable y is level of humidity, which is it shows in percentage, while the independent variable x is time, which is its measured in seconds. So we jump to the calculation.
Okay, next I will show you how to calculate using calculator. First, input the independent on the x section and dependent on the y section. And then click SC option number 2. Here you can see the mean, summation of x, y, summation of y, variance, summation of EXY, minimum value of x and y, and maximum value of x and y. And then click option, click number 3. By here you can see the value of beta O, which is A, beta 1 which is B, and R is the percent value.
Okay, from the calculator, we have obtained summation of x, y, xy, x squared, and y squared. And then we have to calculate as xy. and SXX to obtain beta O and beta 1. For SXX, the formula is summation of xy minus 1 over n multiplied by summation of x multiplied by summation of y. After we have input the value, we get SXY equal to 117,328.8. And then for SXY, we get the formula is summation of x squared minus 1 over n multiplied by summation of x square root. And then by inputting the number, we get SXX equal to 1639390. And then after obtaining both xy and sxx, we can continue to calculate beta 1, which is sxy divided by sxx, and we get 0.01358, while beta O equal to y minus beta 1 multiplied by x, and we will get 7.778. While for syy, the formula is summation of y squared minus summation of y square root x squared multiplied by f divided by n, and we get 1793.0547. And then for SSE, the formula is SYY minus beta 1 multiplied by SXY. After input the number into the formula, we get 202.076. For MSE, the formula is SSE divided by n minus 2. And then we will get 7.217. For the t-test, the formula is beta 1 minus beta c divided by square root of MSE divided by SXX, and we will get minus 1079.257. While for R squared, we will using formula SYY minus SSE divided by SYY, which will later will be equal to 6.967, which for the Pearson value, R equal to SXY divided by square root XXX multiplied by SYY. When we input the value, we will get 0.94268, which is similar with the one that we have calculated.
Okay, now we will analyze the data by using the SC10 software. Okay, firstly we need to enter the independent and dependent data. For independent data, we set time as independent. For dependent, we set humidity as the data. After enter the data, you can change the variable to its names. Like for the independent, set time, and for the humidity, we set as their dependent. Okay, for first question, the question asks to state the mean, standard deviation, minimum and maximum value for independent and dependent variable. To find this data, firstly, we need to click the analyze. Click at the descriptive statistic and click the descriptive. And then it will show these two variables, time and humidity. So for this question, they need two data from independent and dependent variable. So we include these two information and click the option. Here you need to choose what the information that you need. So here has the standard deviation, minimum value, maximum value, and we also need a variance. Okay, and then continue. After all setting, click OK, and the data will show in the screen. So here for the time, the n is 30, minimum value is 0, and the maximum is 1798. For their mean is 899 and the standard deviation is 545.81132. For their variance 297910. Okay, for humidity, the data that we use is 30 sample. For the minimum is 77.2 and the maximum is 96.6. And the mean is 86.9867. For the standard deviation 7.86317. And also the variance 61.829. So for the next question, B, show the scatter diagram and regression line for the data. On this question, firstly, we must show the scatter data. Click on the graph, go to the listing dialogs, and click on the scatter dot. Just a simple scatter. So on y-axis, we put the humidity, and for time, we put the x-axis. Okay, at here you can write the title. Okay, first we show humidity versus time. Okay, and click OK. So the graph we got here. For this is a scatter diagram. You can see here from the 0 to 2000 time, and for the humidity 75 to 100. Okay, so then we need to show the regression line. So to show regression lines, double click to this graph and add fit line and total. Here, choose the linear, add the fit method, and the graph of the regression will show up on the chart editor. So this is our regression line, and this is their equation for B0 and B1. So the data will show for the regression line and the scatter diagram. To find the simple linear regression model, we also can find it by click on the Analyze button. Go to regression and click linear. Put the dependent and independent data like before. Click statistic. And we set our confidence interval 95%. So we click. And we also need descriptive. And click on it. And then OK, click OK. The data will show here. The mean of the humidity like before, 86.9867. For third column, standard deviation, the humidity standard deviation is 7.8317, same as before. This data has shown before. Mean and standard deviation of humidity and time. Okay, for R value, we can see here 0.943. This is R value, and the data that we use is 30. Shows here for humidity and time. And then the data also show here to more clear. is the y-intercept and V1 is slope regression coefficient. Okay, here show the V0. V0 is 74.778. This is y-intercept. And for the slope is 0.014. This value is shows in the graph. You can see before here. Okay. For the t-test, we cannot use this because we use the two-tail data. This is the beta 0.943. For the F regression, we can see 1, residual 28, and the total of these two DF equal to 29. So in this software also we can show their probability distributor graph. We click to show it, we click the analyze. Click on the regression again. Click linear. Statistic. Setting like before. Teleplots. Put the ZP red to X. And ZP series. Click on the histogram for the graph of the normal probability. Okay, continue and click OK. And the graph will be plot here. Right. Okay, here it shows it. Like we said, R 0.943, same like our calculation. R square also 0.89, same as our calculation. And this is our graph of normal distributor. Okay, for the test hypothesis for this data, firstly we need to click the analyze and go to the compare means and click one sample t-test, and then put the humidity in the test variable because it is a dependent data. We want to test the data and click the option and set the confidence interval percentage 95 because the level of significance is 5% in this data in this question, and click continue. For the test value we set 0 because the V0 and V1 is not equal to 0, so we just put it at 0 and click OK. So this is the result of the test. It will show the mean and standard deviation of humidity data. It's same as before. And for the one sample test, this is the result of the test, and it shows 60.592 for the test result, and the DF is 29, the 30 minus 1 you get 29, and for the mean difference it shows X is 6.98667. Okay, this is the result that we get from the SPSS software for this data. Okay, all the data is compared with the manual data and it's same. And that's all for our group. Thank you.